Just wait for a second. Please, everyone, mute your mics. If you have any question or any doubt, then we'll unmute yourself. Yes, this recording will be available. Like, I'll upload it on YouTube and I'll give you the link as well. I'll share the channel at the end of the lecture. And I'll try to give you the notes as well. Just wait for a second. I'm trying to. Is my screen visible? Not audible? Okay, someone is saying not audible. And is my screen visible?
Madam, both are okay, madam.
Screen is also visible?
Yes, ma'am.
Yes, ma'am.
So introducing myself, I am Prableen Kukreja, an IIT scholar, basically PMRF scholar. So I hope so you have seen the lectures of Professor. Now coming to computer networks. Wait a second. Before starting the lecture, I'll ask you, what is computer networks? Before introducing everything, let us first try to understand. The screen is not visible. Okay, wait a second. That is okay. Meanwhile, let's have this as one on the session as you should also reply me and I should also it shouldn't be one-way session that I'm only telling you. You should also reply me. This should be two-way session. So first of all, what is basically computer networks? Before going in depth of this networks subject. Yes. Okay, screen is not visible. Meanwhile, can you tell me?
Visible, ma'am.
Visible. Okay. Now, can you tell me what is computer networks? Any of you can basically unmute yourself.
Two or more computers, autonomous computer connecting to share the information.
Okay. More
Now
computers.
multiple devices are connected. Multiple
Yes,
devices
yes.
are connected.
Both are correct. Two or more autonomous computers or multiple devices. And now are these devices only computers, as you said, or they can be something different also, some other system also?
Yes, ma'am. It should be another system like a LAN, WAN also we can
Servers, routers, anything it can be.
yes, ma'am.
And why they are getting connected?
To share the information between the source and the destination.
To share the information. Can I say that they can share the resources as well?
Yes, ma'am. Not only information, whatever we are having the resources or something else, we can share the information.
Yes. So basically,
in my opinion, computer networks is all about how we are communicating with each other, the help of computers, sending information, receiving information, security, and how the IT infrastructure works. This is computer network.
Please unmute yourself if you are not answering the question. Please unmute yourself. Many of the mics are I mean to say, please mute yourself if you're not asking the question. Please mute yourself if you're not asking any if you're not answering any question or if you're not asking any question. So yes, as you said that it's like information sharing between two computers. It can be information sharing between, let's say, any two any two systems, which can be routers as well. It can be servers as well, and it can be exchange of the data, or I can say sharing the resources as well, like sharing the data, sharing the resources. It can be like that also. So what do you mean by, if I'm saying that resource sharing, I'm mentioning that, okay, is okay. What I mean by resource sharing if I'm mentioning computer network? Okay, you'll answer in the chat box. It's fine. Please mute. I'll request everyone to mute your mic. Answer in the chat box only, as there's lot of disturbance. Obviously, in the recording also there'll be lot of disturbance there. Sharing memory storage, yes. Or I can say if hardware sharing can also be happen. Like if I say about printers, scanners and all, is it also type of network only?
Yes.
A different,
Yes, ma'am.
and what about software sharing? I'm taking into different angles so that you should, yes, printer sharing. You're right. Bandwidth, okay. Software sharing. Can I say if I'm centralizing the application any? That is also allowing user to share files, printers, and other resources. Absolutely correct. Software sharing can be like all the applications, yes. Remotely when I'm accessing the application, what is the advantage of that? Basically,
I
all
can access application through mobile as well because of my application server or my computer network.
Okay. What if can I access the application? You are saying that, okay, if it's in the mobile, I can access that. What if the application I'm accessing from others' system? Is it possible that application is installed in other system and I'm accessing that?
Yes, it is possible if the application is available like through the web. I can log in the network using my authentication username password. I can access the portal through that. That is also a network using the internet. I'm not in the office, I'm outside, I'm somewhere else, but I can still log in the portal using the network username and password.
Yes, yes. Wait a second. Let me check whether the recording is happening or not. Here it's showing, okay, yes. Yes, absolutely correct. Like I can access the application if it's in another system also by remotely accessing them. Yes, everyone, you are correct. Even by taking remote access of the system, yes, it's absolutely correct. And first one is resource sharing. The second is obviously the communication. That is the basic one, what we do basically in the computer network, what we understand by the computer network. That is communication, which can be through email, messaging, video conferencing as well. And I can say data management also by centralizing storage. This is basically computer networks. Will the recordings be uploaded? Yes, the recordings will be uploaded. I'll like these all these questions I'll answer at the end of the lecture. Let's first focus on this lecture today, whatever I'm teaching. After this, whatever doubts you are having, I'll answer at the end. The recordings and all, the channel, YouTube channel, everything I'll answer. Please mute yourself. Now, as we have discussed what is computer networks, at this we'll go through the computer networks layers. We'll go through each and every detail, every layer in the coming lecture. Today, the main focus of this today's lecture will be giving the outline. I'll give the outline of the course, like what basically we'll go in. I'll teach in the further lectures. Today, it will be just an overview of everything. every layer, everything. Today I'll give the overview of this. So basically how the computers are talking, how the computers are sharing, how everything is happening, that is basically the computer networks. Then, as we have also this diagram you may have seen in the lecture as well. I'll try to cover the lecture detail, lecture things, as well as I'll go much somewhat in detail of those things. I'll also come up with some questions also, and then you can give me the feedback how we can proceed in the coming lectures. So coming to this, what do you mean by protocol? What is this diagram? What do you mean by protocol? What is this? Network architecture is binding or tying these functionalities as well as protocol. What is the
All the
protocol?
rules and regulations which is taken care for communicating in between two or more than two systems. That depends on the network.
Yes, basically all the rules and regulations which have to be followed to achieve the functionalities. That in the simple language, I can say that is basically a protocol. Now coming to a network architecture, if I say about the physical layer or a simple network architecture, this is a system 1, this is a system 2, and they are binded by a wire, suppose. Now this is a physical medium through which they are binded up. We are connecting it by the wire. It can be wireless also, the physical, this system, connecting these systems basically. Now what is the use of this physical wire? Can anyone tell me?
Data transmission, the basic layer, physical layer.
Yes, data transmission.
This wire is actually used to, because our last application layer, last layer, physical layer, that is actually convert our digital signals to the analog signals.
Yes.
This wire is communicating this analog signals to the other end, where this is again reconverted to digital signals.
Yes. The person who is answering only should unmute. Please, others, mute yourself. I don't know who. I think you're absolutely correct. At one end, we are converting the digital data, which is generated by this system, to the analog, which is carried by the wire, and at the other hand, it is reconverted into digital system. Basically, digital data is converted by the system. Now, in order to send it, the transmission medium or the wire, it is converting to analog, and then analog is being reconverted at the other end to the digital, so that system should understand. So underlying network interface is basically converting them, and it is carrying it, as one of you said that it is a basic layer. Yes, it is a basic layer which is carrying that signal basically. Now what if we have more than one system? Now, will the wire be helpful if we have more than two systems for the communication? What do you think?
Yes, wire is helpful because we have to put some network hardware in between, like switches or hardware or routers or even hub even. And that will be there. If we are using the hub, then this particular signal will be routed to all of the networks that collision might be there in hubs, in the case of hub. But in the case of routers and or switches, it will be eliminated little bit.
Yes, I'll come to that. As you said about hub, let's focus on the hub first. So what is hub? Can someone tell me? Okay, as you all are answering, it can be switch, routers. Yes, there'll be collision. We need switch, specifically L2 switch. Okay, I'll come to switches. I'll come to everything. First of all, let's start with the basic thing, that is a hub. Hub comes in which layer? And okay, we are now connecting more than two systems, so that is why we need some other device like hub, switch, or anything. Now, hub or switch, why we need that? Because they are multi-port, I can say. That is why it can connect more than two devices. First thing, can someone tell me about this hub thing? What is hub? It is a physical layer only. Now, what is hub? What is the functionality of hub?
It is hub is used as a multiplexing type of device. When the system A is passing some data, it will be routed to all of the data connected to the hub. Suppose 4-port hub is there, so that particular data will be routed to all of the hub.
It's the interconnection model.
You all are correct. And people who are messaging also, hub's broadcast message. Hub is a device that connects multiple computers. Okay. And as you said that if one is speaking, then the other will listen. Basically, it is a broadcast medium. Yes, that is also correct. Now, the two words were used in the lecture also. One was collision domain and the other was broadcast domain. I'll come to this hub and I'll come to everything. First of all, I want to see that you know about this collision domain, and I'll give you a layman example also to give more clarity about this. First of all, what is the collision domain as well as broadcast domain?
Not what the area, bro.
Don't share WhatsApp links here. I'll share maybe a Slack link so that any doubts will be there in the next lecture. You can message me there as well. So yes, what is collision domain, broadcast domain? Any idea?
Collision domain.
Your voice is cutting. Please write in the chat box.
Networks means
Whosoever is answering,
the networks they get
can everyone hear me properly as someone is writing in the chat that there is a disturbance? Everyone can hear me properly as someone is writing that there is a disturbance? Okay.
Yes, Sam, your voice is very clear.
Okay. Okay, actually disturbance is from the other end. Please mute yourself if you're not speaking, if you're not answering any question, if you're not asking any doubt, mute yourself. I'm again and again speaking. Okay, yes. Broadcast domain and collision domain. Let's focus on that. Yes. Yes, there is a collision in the Zoom call.
Yeah, when multiple devices try to send data at the same time, then that data will collide and that packet will get lost.
And what is broadcast?
Broadcast domain means our network is broadcasting message to all the devices connected to its port. Hub will broadcast whatever message it get from one port, it will copy same message to all other ports.
In the particular broadcast, when the message is broadcasted, then only the device or whom this particular message is broadcasted, that will accept only, and rest will discard the same thing. But in the collision domain, like how it will be sent to all of the devices, but the devices, that particular device which is capable, that will only accept, and rest devices will send it as a collision of the data.
Okay, collision domain. Okay, let's come to an example. I'll give you more clarity about that. Now, collision domain is as where the data, when we're getting the data, it is basically getting collided.
Communication engineer.
Yes, yes.
Network protocol telecommunication.
It will be better if you write in the chat. Yes, it will be better. Don't unmute yourself because there's a lot of disturbance. I think 180 students have joined, and mute yourself and write in the chat box the answers rather than answering here.
I think we can raise hands if we want to speak, and then you can allow that person that you can speak or not.
Please, others, mute yourself. Or you can write in the chat or raise hands. That's a better idea. So when multiple devices are sending the data over the shared medium, yes, you are absolutely correct. That is basically the collision domain. Broadcast is basically when one is speaking and everyone is listening there. That is a broadcast domain. If I talk about the hub is basically everyone is talking there. That is, they are having the shared collision domain as well as shared broadcast domain. I'll come to the detail further, but when I'll explain the switch. So basically, they are sharing this. So there is lot of collision. They are receiving also, everyone is receiving also, and everyone is sending also together. So there is a collision. And if there is a collision, what can be disadvantage of collision? I'll come to the collision domain and broadcast domain in detail. Just wait for a second. What is the disadvantage of collision?
We will lose the packet. We will lose the data.
Yes, we'll lose the data. Please write in the chat. It's better. So we'll lose the data because we may lose the data. It may also happen that there is a mechanism of acknowledgement or something, and we'll get to know, the system will get to know, okay, the packet is lost or we haven't received the packet, and retransmission may happen. And if retransmission is happening, I can say more time it will take. And if it is taking more time, obviously it is inefficient, I can say, in other words. Or I can say that we'll lose the bandwidth. I'll share the basic details as well. What is bandwidth first? Can you write in the chat? Yes, Aman Kumar, you are absolutely right. Bandwidth is too much used inefficiently. Data need to be sent twice or maybe thrice or maybe 4 times if the retransmissions, if they're colliding it multiple times. Upper frequency, lower frequency. Can I say bandwidth in the easy word, like easy language, that it is a capacity of the system to transmit data within specific range of frequency? Basically, what is the capacity of the system? If I say, if I relate it to the real world, like suppose a highway is there. So what is the capacity of the highway that, or width of the highway that at one time multiple cars can travel at that highway? That is the bandwidth. Yes, you are absolutely correct. Bandwidth is the maximum amount of data that can be transmitted over a network connection in a given amount of time. Correct definition. Now, as we saw that we have a shared access, sharing the same collision domain, more devices, and if there will be more devices, more collision will be there for the hub. And if more devices are there, more collision is there. So obviously it's not scalable as well. I can't add more devices because more collision, so much of time it's consuming because of the collisions. It is inefficient, lose of bandwidth. So there are many issues. So that is why we switched from hub to switch, basically layer to switch. That is a data link layer. So we saw that in layer 1 there was a broadcast behavior. Any data packet received at one port, it is broadcasting to the other one, and there is no traffic management also. So that is why many people call this hub as a stupid device. Everything is clear till now? Should we proceed? Now coming to switch, basically. Now, what is the difference between switch and hub? Can someone write in the chat? Write in the chat. Yes. Okay. Switch filters what data has to be sent where. Okay. Switch is layer 2 device. Yes, obviously. It sends message to the desired host. Okay. Switch uses MAC address. Yes. It's a data link layer device, so it is using MAC layer address. It's given, okay. It's given access to what about collision domain? I want the answer. No one has answered in the line of the collision domain. It divides collision domain. Yes, basically. It is not using, absolutely correct. So I'll give you visual representation. Suppose there is a single room. If two two people are if more than two people are speaking, I'll say that obviously at the same time there'll be collision, conversation overlap, so there'll be collision. Now many people, if more than two people are there and they are given the multiple rooms, everyone is speaking at the different room, at their own room, so they can talk simultaneously in different rooms, so there's no collision. So that is what it is, a shared collision domain. It is a different collision domain is given to everyone. If I say why switch is multi-port bit, switch divides collision, okay, handles collision, it divides collisions, which is intellectual device but not hub. Yes. So basically, different, when they are speaking, when they are sending the data, they are sending at the multiple rooms. I'll say they are sending at the different domains. That is what we are not sharing the space. We are not sharing. They are not sending in a single room. In other layman language, I can say. So obviously, there'll be few collisions. So more data will be transmitted, and it will be fast, obviously, because it is without retransmission. That is why. And it will be more scalable. Why people suppose it is a small office and it's fine, if we have 10 computers, I can use the hub. But when the office is suppose I'm scaling the office and I'm adding more devices and I need a good network performance, obviously I have to switch to the switch, basically from hub to the switch. Now what about broadcast domain? Collision domain is about sending.
Can I ask something?
Yes, sure.
Can I say that the basic difference that I have understood between hub and switch is that both work in communicating and transmitting the information, the data, but switch is smarter device. It can route the traffic to the point that we want to send, avoiding collision with the other transport other transport way.
How it can your answer is correct that it's a smarter device, but how it can reduce collision?
Like you said that there are people sitting in a different locations, for example, not even room, I'm saying different locations.
That is, yes.
Right, so it is covering more area, and they whosoever is sending the message is will be received at other end, and if there are multiple people speaking, the switch can decide that which message is going to which machine or which person, so the route will be more clear than in comparison to hub. I'm just saying
One
I'm
line
not
you
able
said that you are okay. One line you said that you are increasing the area. We are not increasing the area. We are partitioning the area. Like suppose A, B, C, D. Here, 3 devices were there. I partitioned it. I said that okay, AB will sit in the partition 1 and CD will sit in the partition 2. They'll speak in the partition 1 and they'll speak in the partition 2. They'll send it partition 2, so that there should be no collision. Understood?
Yes.
But broadcast domain, still it is shared. That is what someone, Aman Kumar, has answered. A broadcast domain requires L3 switch or router, as it helps in distinguishing which network is data being broadcasted to. Router divides broadcast domain. Yes, router do divide broadcast domain. If I say broadcast domain, so broadcast domain is now they are sending the data in their own partition, but when someone is broadcasting, they all can hear. If suppose there is a someone is broadcasting, AB can also hear and CD can also hear. Now the limitation here in data link layer is that they are sharing the same broadcast domain. What does it mean? That if there are suppose many devices are broadcasting, then again there'll be I'll say there is a frequent announcement in layman language.
May I say something?
Yes, sure.
Is it would you like to say that suppose there are, for an example, suppose there are 4 persons, 1 2 3 4, one is called 3, right? So in this case, number 2 and number 4, they are also listening, but the number 3 is listening as well as the answer will be reverted by number 3 only. This is the case. Is this the case in the broadcast domain?
You're saying 1, 2, and 3 and 4. Okay.
1, 2, 3, and 4.
Hmm.
1 is calling 3. In this case, number 2 and number 4, they are also listening. It means broadcast messages also pass to number 2 and number 3. But the packet will be received by 3 because I am calling number 3. And answer which I am going to get, that will be from number 3 only, not by number 2 and number 4.
I'll tell you. Suppose, as you said, A, B, C, D, or this was the partition. 1 is calling 3. No, here 2 and 4 will not listen. There is a broadcast. Suppose there is
no partition. In this case, the example which I am depicting, in this case, there is no partition.
Yes, then that is not data link layer. That is a hub physical layer. When all are listening, I'll tell you. I know there's a confusion that I'm saying if broadcasted, then everyone can hear. You are saying that if one will send, then everyone should hear. If I'm saying that broadcast domain, everyone will hear. Okay, let us take an example. I have an employees in the company, and suppose there is a partition. I'll come to that answer. So now A is transferring to C. C will only hear, but there is a manager here. Now, if manager is broadcasting the data, then everyone can hear. That is sharing broadcast domain. When A is sending to C, then it's not like everyone will hear. When a central manager is sending a broadcast message, then everyone will hear. Is it fine?
Ma'am, can I ask something?
Yes.
In broadcast, normally, like if a message is broadcasted, it is like it will be everybody will be able to listen to it, but they may not be able to reply back. Is it so?
No. They may, they can send the unicast message as well. Here I am talking about, yes, they may send the unicast message as well. Okay, yes, as people are suggesting that I can take doubts later. I'm also thinking the same because it's half an hour over and a lot of things to cover. So keep doubts ready. Write in the notebook or notepad, so that or write somewhere else. I'll dedicate 15 minutes, or you can mail me also. I'll first try to give you as much content as possible, and we can discuss it later on. I think I have answered your question. Should I proceed? So broadcast, basically, suppose this is a manager, and manager is basically broadcasting and everyone can hear. But if A is sending to C, then C will only hear. And now what is happening in data link layer? Now suppose there are a lot of managers, I'll say that it is a huge company. So there are a lot of managers, I'll say, or you can write in the chat the doubts basically. I'll maybe try to take it later on. So like what is happening here? So in broadcast domain, everyone can hear when someone is broadcasting the message. And if there are a lot of people who are doing the frequent announcement, lot of people who are doing the broadcasting, obviously it will lead to congestion, because a lot of messages are coming to every device. So it can lead to congestion. Same thing again, the scalability issues will be there. One more thing can happen. Security concerns can also be there in both of them, hub and let's leave that. Main is that again, the scalability, network congestion, the same thing will happen. Now this basically issue is solved by the network layer. In network layer, write your doubts in chat box, it's fine. Different collision domain will be there and different broadcast domain. So basically now different collision domain as well as different broadcast domain is there. That if someone is broadcasting also, they should broadcast in AB differently, CD differently, and like basically different partitions differently, rather than broadcasting and giving an announcement overall, so that there should be it shouldn't happen that many people are announcing and there's again the collision thing is happening. So that is what is solved by the network layer. And network layer do have other properties as well. As we know that network layer basically is helpful in routing, finding the path, choosing the optimal path, and they go hop to hop. Okay, can you tell me in the chat box only the functionalities of network layer? The other functionalities? Yes, come on, fast. Yes. Works with IP address, yes. It works hop to hop. It works with the IP address. Find the optimal path to route the data. And can we, now the other question I'll ask, can we see the global view there? Can we see the global view, the whole data route? Can I see that? Global view in the sense I can see the whole route which sender has to send to the destination. Yes or no? Yes, come. Yes, okay. Yes, in circuit switching, yes, no. Okay, someone is talking about circuit switching. I'll come to that later. But router basically doesn't see the everyone. Most of the people have answered yes. Some of them have answered no. Actually, the answer is no. We can't see the global view. That is why I'm saying it's hop to hop. I can see only the next hop, path, next hop basically where to go. So basically it's like I can see the next destination only. I can't see the overall destination, like sender has to send from A to D. I can't see what is the route to the D. I can see, okay, suppose A is sending to B, I can see the B only. Here I can see C only. Here I can see D only. I'll come to circuit switching and packet switching and everything. Would you like to see routing table? Obviously yes, we'll see the routing table and everything, but it will tell us the next hop only. So I can't see the overall paths condition. I can see only the next destination. And it doesn't do end-to-end transmission also. And that is why we call it as unreliable delivery. It only decides how data should be. Would you like to see routing? Okay, yes. So if I talk about an example, I'll say that it's like using, like suppose postal service. It's like using zip code for address, not end-to-end transmission. Okay, this is a zip code, this is what this address. But if I talk about transport layer advantages, like it's like end-to-end transmission. It do see the global view. And suppose it is the data is not transmitted at the end, suppose till the D, it will again retransmit it. It will handle the loss. It will handle the damaged postal mail. Basically, it will handle all those. So that is what is advantage of transport layer over the network layer. Now coming to the transport layer here. I hope it's clear. Transport layer only provides end-to-end transmission. Yes, you are correct. Transport layer do provide end-to-end transmission there. And this is how we move from physical layer, as we saw that it is a hub. We also call it as a stupid device where it can't manage the traffic, share the same collision domain, same broadcast domain. Then we came to network data link layer, where we saw that it is sharing the broadcast domain, but different collision domains. Still there was a congestion there. Then we moved to the network layer. There we saw that, okay, now broadcast domain is also different, collision domain is also different, so that we can reduce the collisions and everything. Then we saw, okay, it's not doing the end-to-end transmission. Let's move to the transport layer, which is more reliable layer. Then we move to the transport layer, and then comes the application layer. So basically, suppose there is a system. This is a router, then switch, and then a system. Now coming to which layer this system, this application will work, to which layer the router will work, to which layer the switch will work, and to which layer this will work. Can you tell me? Yes, Somnath, the recording will be provided. I'll answer at the end of the lecture about the details of the recording. Router layer 3, yes, absolutely correct. switch layer 2, absolutely correct. And this application obviously till the end of the application. I can say that. Now we have different protocols, R3, S2, AA, SS. Absolutely correct. Now coming to, we have different protocols as well, like application layer offers like HTTP. These all we'll discuss: TCP, transport layer, network layer, IPv4 and everything, data link layer, Ethernet and everything. And there are also cross layer protocols as well, like DNS, it is following the application as well as transport layer, SNMP, transport and network layer. These all will come later on. Now coming to the internet history. I'll go very quick with this because this is just the reading part which you have to follow. Just the main things I'll cover here. If I talk about telegraph, I'll just jump this part. Basically, it was invented first, the network device 1836. It was like we have to transmit in dots and like they used to transmit in dots and dashes, which were representing the letters here, just as we transmit now as 1 and 0. This you can read it yourself. Just I'm giving you the overview only. That also I'll not cover full. Transatlantic. Basically, yes. 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 Any doubt? Okay. Okay, let's proceed. So transatlantic, it was somewhat reliable, fast means of communication. Basically, it was from North America to Europe, I can say. Basically, it was to overcome the vast distance, I'll say, of the harsh condition of Atlantic Ocean. Then came the ARPA, Advanced Research Project Agency, by Soviet Union. Then ARPANET, when they saw that, US saw that, okay, that like Soviet Union has done the invention of the Sputnik 1 satellite. They also thought that they should also do something in the network line. They are weakened in the network line. So they collaborated with DOD and they came up with the ARPANET. And the first application of ARPANET was email, which was by Ray Tomlinson. And the first email was sent, basically. So this is whole history. I'll not discuss this. Just this was the overview. Yes, I will share the recorded video. Don't worry about that. I'm repeating it again and again. Okay, this you can read from the lectures as well about the history. I'll not go in detail with the history of the internet. You can, should I proceed further or you want me to discuss about that? I think so. It's not that much explanatory. I think so. So let's proceed. Coming to what is protocol? So as I have discussed in the earlier part of the lecture as well, what is protocol? As you told me, okay, the protocol is a set of rules so that we can share the information, how the data is transmitted, received, interpreted, basically. That is basically the protocol. Some of the characteristics can be standardization. Why we need protocol? There are a lot of questions here. First is standardization. If I am following any standard, then the other person is also following the same standard. I don't need to explain how the things are working at the other end. And it do manage the network traffic. I don't need to send the separate documentation to understand what I'm sending, what is the header, what is the footer, everything in detail. Because they know the standard. This is the standard protocol which I am following. And then data integrity and security is also there, as well as it also manages network traffic. Coming to human analogy. I think so. I'm not going that fast. I do speak very fast, so I hope so. So human analogy. Suppose I'll give a simple example. There are two people, person 1, person 2. Person 1 sent the hi message. This is how basically the communication is established. Person 2 also sent the hi message. If one will send, and then person 1 send the what is basically time. What is the time now? Then the person 2 will reply. This is how the communication is established. If I want to know the time of the day, the person 1 will first offer a greeting to initiate the communication. Then the response will be hi. Or if the person don't want to respond here, then the person can say, okay, I don't want to talk to you. I don't want to speak in English. I'm unwilling. The person will ignore. Or if the person don't know the concept of time, it is the person is mannerless, which I mean to say, if the person run different protocol, the person will not reply because it doesn't know how to reply here, how to speak in English, or how to. That is basically the protocol advantage. Now if I talk about the network here, the same way, here the connection request is there by the sender. A connection reply is there. Then like suppose I get messages there, and then the file is basically sent here. So basically this is how the communication happens, but there should be a proper protocol which has to be followed. That is what I mean to say. And if a proper protocol is followed, then only we can communicate. And in internet, everything, every remote entity, it is governed by the protocol only. Like if I say about like congestion control protocols are there, how much control, like how much rate the packet should be transmitted and sent. When I'm asking for the URL here in the get packet, then they are replying for the like file here. That is what they are replying. They are fetching the file there, the web server. So I can say that in other terms, protocol, it defines format, order of messages, exchange between two communicating entities. So basically this is the protocol. Okay. 3 handshake, I'll say. I'll come to this handshake also. This was just just to give you the glance that okay, if you know English, if you're following a particular protocol, then only it will reply, it will initiate the request, like it will reply to that request you have established. The reply message, the connection reply message, then will only be established if you're following the same protocol. Now coming from TCP/IP to I'll say OSI layer. Can someone tell me what is the difference between OSI and TCP/IP? Are they doing the same functionalities, or they are following some different functionalities? Are the layers same as we saw? Physical layer, data link layer, network layer, transport layer, application layer in TCP/IP. Now what is in OSI? Okay, OSI have 7 layers. Absolutely correct, everyone. TCP has presentation. Okay. Can you tell me what are the extra layers? Session, presentation. Yes. Yes, session and presentation. And like, are they doing extra functionalities, or they're doing the same functionalities? Yes, some books have that TCP/IP has 4 layers. Some have 5. Like some are mentioning 5 layers. It's fine. Same functionalities. How same? Presentation and session is not there in TCP/IP. Yes. Session, application, presentation. Yes. Application is basically comprises of session, application, as well as presentation. Fine. Now, what about now? Let's come to the next part. I was going to give the examples. Okay, let's go. Can someone tell me about LAN and WAN? Within a building, network connection is LAN, geographical area wise, physical plus data link layer host to local area and wide area network. Yes, I'm not asking about the full form. Can you tell me what is it? Only difference is area covered. Please, Tara, can you mute yourself?
LAN is like same building, and WAN can be two different buildings.
Yes, absolutely. Trying to mute. LAN can access only in the community. WAN can access the network anywhere. Yes, you are absolutely correct. Now coming to, I'll not go in detail. As you know, there is a geographical difference only. So I'll further describe about, and okay, encapsulation is left. Okay, I'll come to that. Maybe I missed that encapsulation part. Okay, I'll come to that afterwards. So wide area network, obviously it's covering a large geographical area as compared to local area network. Now coming to the devices which are used there. First of all, NIC. Can you tell me about NIC?
Network interface card, ma'am.
Can you please write in the chat box, because there's a lot of disturbance when one speaks. Yes, network interface card. Can you tell in detail, everyone? Which layer it is? Network interface card. It is given by manufacturer on every computer. Yes, because it's a layer 2 device. MAC is being used. That is why it is given by a network manufacturer here. And what if I go more than 100 meters? Will NIC be helpful for me, or I have to switch to another device? And it's also used for amplifying the signals and all. That we know that it's a unique 12-digit alphanumerical character, because I'll come in detail about MAC address and all. For greater than 100 meter, we need a repeater. Yes, absolutely correct. We do need a repeater. And then we come up with the, if we need if we have to go for the more than 2 devices for the multi-port thing, then we do have to move to the hub here. And the hub also, I'll say, share the bandwidth between the devices. So if total bandwidth is 8 Mbps and I have 10 devices, now how much will each device have the bandwidth? Can someone tell me? Okay, someone has answered. Network interface is a hardware component that allows computer to connect to a network. It acts as an interface between devices internally. Yes, absolutely correct. Obviously 8/10. Yes, absolutely correct, Pratham. Because it is sharing the bandwidth between devices. Now hub also cannot filter the traffic here, and they are using broadcast medium, which everyone can see. Now coming to bridge. What is the difference between hub and hub and bridges? Bridge do filter the traffic based on the MAC address. Can I say that? And what is the difference between bridge and router? Yes, bridge is like a switch. Bridge filters the traffic, but half duplex. Yes. What is the difference between bridge and router? Can I say multi-port bridge? If I say router as multi-port bridge, am I right? It uses MAC address, yes, and it is using IP address, yes. So basically, it's a multi-port bridge, I'll say. And one more thing is that higher layer, it is and broadcast domain and everything that we have already discussed, that will be there. And the higher layer will have the properties of all the lower layer. If I'm using the layer 3 device, I'll have all the properties which are in the layer 2 device as well. Now coming to switched network. Basically, switched networks are those that are using network switches to connect devices. They are not concerned about the data, content of the data. They are only communicating between like these end devices, I can say. And if I say about hub-based network and switched-based network, have the difference here. If I talk about data transmission, first difference. Can I say here it is broadcasted? Here we can send it directly. If I say about collision domain, I can say it is shared here. Here we have separate bandwidth. Can I say here it's low? Here it's high as compared to hub-based network. Security also, because it's basically broadcasting, so low security also. Here it's high. Scalability, yes. Low. Here it's high. What about cost? What about cost? It's little bit high, yes. Basically, it's cheap. It's expensive. And use case, if I say, it's basically for the small network. I don't have to invest that much of money. If I am having a very small network, it's small to large network. These are the basic things we can understand from both of them. Now, coming to circuit switching and packet switching. Let's discuss this in very much of detail. I have also prepared MCQ questions for this. Okay, maybe MCQs was going for the MCQs I'll discuss after explaining you about the circuit switching as well as the packet switching. First of all, I'll give you the overview of that in much detail so that you can understand. What about packet switching? Let's start from the packet switching. Can you tell me about packet switching? What is packet switching? Can I say data is transmitted in the small packets, in the form of small packets? Packet is data broken up. Yes, sure. Data is basically broken up into packets and it is transmitted like that. They are moving independently. Whole data is not moving together. They are moving independently. And they use store and forward mechanism. Over different routes and merge at the destination. Absolutely correct. Not have dedicated path. Yes. No predetermined order of transmission and reception. Absolutely correct. So basically packet switching is they are not having any predetermined route that they have to follow a particular route. They are going as a chunks of a smaller chunks of a data, and then they are there reordering at the other end. Now if suppose packet switch is sending a packet of L bits and the transmission rate is R. How much time it will take for to transmit the packet? How many seconds? Yes, absolutely correct, Shrisha. L by R. Yes. So basically, simple thing. Data is transmitted L bits and rate is R. Then the time obviously will be L by R seconds. If I talk about store and forward transmission, what do you think? What is store and forward transmission? Copy of data in previous node. Okay. What about others? Store means packets are stored in the buffer. Yes, absolutely correct. Packets are stored, like basically they are stored in the buffer and then forwarded. Why they are stored? So what is happening? Store and forward transmission.
Sorry.
Store and forward transmission means that the packet switch, basically they must receive the entire packet first of all before. Maybe I'll show you the image. This is the image. Can you tell me what you are understanding by this? Copy paste in the notes only. What you're understanding by this? This is taken from the book only, I think. When we have to send data from A to B and more hops are in between, then all hops will store the forward, can retry if packet receives all the packets are then sent. Yes, absolutely correct, Sucharita. Basically all the they are receiving all the not all the packets, basically the whole packet they are receiving, then they are basically sending. That is what it is happening here. First packet is fully received and it is stored, and then it is basically sent. That is what it is meant by the store and forward. Packets, basically it must receive the entire packet. I'll write it so that there shouldn't be confusion. So this was the front of the packet one. It must receive the full packet. Not all the packets, full packet it should receive. And then begin to transmit. So it is storing basically in the buffer so that whole packet should be received. I'll say. Now, how much time it is taking? When the first one, I'll say the time, as we have seen that it is L by R. And this is the router here. Now, when the first one basically is sending to the router, it will take L by R. Now, the L by R, this packet, the packet is received by the router, the packet one. It took L by R time. Now, the packet one will be sent to the destination and packet two will be sent to the router. The time is now 2L by R. Now, at 3L by R, the packet 2 is basically sent, as well as third packet is sent to the router. And at 4L by R, the third packet is sent from the router to the destination. So total time is basically 4L by R. Any doubts? First packet was sent to the router, L by R time. Then the first packet was sent from the router to the destination, as well as second packet was sent to the router, 2L by R time. Then the third packet was sent to the router, as well as second packet was sent to the destination, 3L by R time. And then when the third packet was sent from the router to the destination, that is 4L by R. This was the total time taken, 4L by R. Now, there can be delays as well as in the packet switching. How? There can be queuing delays. What do I mean by this queuing delays? Suppose, before that, I'll introduce this. Okay, buffer, we know output buffer. If someone is transmitting, if sender is transmitting to the receiver end, and already a transmission medium is basically busy, so they'll wait in the buffer. That is what is happening here. The arriving packet is waiting in the output buffer when the transmission medium is busy. So this time in which when they're waiting in the buffer, that is basically a queuing delay. When a packet is suffering from output buffer because the transmission medium is busy, that is basically queuing delay. Now, here the packet loss can also happen. How packet loss can happen? Can someone think, okay, a medium is busy, they are waiting, how the packet will be lost? Any idea? Overflow. If TTL expires, okay. Connection drop. In more detail, if I want the answer in more detail, what do you mean by overflow? TTL time to live expires or connection drop? Buffer is full. Yes, absolutely correct. What if buffer is full? Then obviously, what will happen if the buffer is full? Either the packets which are residing there, they'll be dropped off, or either the new packet which is going to come there will be dropped off. So that is what is packet loss here. So packet loss can also be happen. So here, this packet switching is based on the network layer, and it is also, I'll say it is using the IP address. So each router will have a forwarding table that we'll go in detail when we'll come to the network layer. Though an overview that everyone will have the forwarding table where to basically go. And it's like, suppose the packet switching is like, suppose there is a car driver. This is the path A, B, C. So from A, suppose the car driver is at A position. It will ask someone, okay, I want to go to G. How I can go? The person will say, go to B, and then ask further. Then he'll ask someone, okay, I want to go to G. How I'll go? He'll say, okay, go to C, and then ask how to go to G. Then he'll go to, suppose he'll ask from C. Suppose the person say, okay, go to D, then you'll ask. So basically it is going to the next hop and then is finding the direction for the other things, for the destination basically. Hop to hop is traveling rather than having a global view, as I told you earlier. So the router, it is examining and like the address at the like hop by hop place, not looking at the global view there. Understood? Okay, now let's go to the circuit switching. Now, can someone tell me, okay, one more thing. I forgot that, okay, we have two techniques here, datagram as well as virtual circuit. Can someone tell me about datagram as well as virtual circuit? First of all, please, any one of you can unmute or write in the chat everything you are getting it. I'm being fast or the speed is normal. You are getting everything. Is my explanation understood? Getting everything. Okay. Now, can you tell me about it is based on TCP protocol. It is connection oriented. Yes. I'm talking about packet switching is of two types, datagram as well as virtual circuit. Basically, if I say about datagram, it is like you can follow any route. It can be out of order also, obviously. And the receivable sequence data packets carry IP address and messages. Yes. So basically, it will sequence it at the receiver end. In virtual circuit, we do have a pre-planned route. It's basically table based, though we don't have a dedicated path that we have to follow this path only, like connection, circuit based. So it's like a circuit within the, I'll say within packet switching only. So we don't have a dedicated path, but we do have a pre-planned route here. So that is the difference between datagram and virtual circuit. Now, talking about the circuit switching. I'll come to the MCQs, then we'll discuss in more detail. Circuit switching. Yes. What is circuit switching? In circuit switching, a dedicated communication path is established between two devices before any data is transmitted. Absolutely correct. Yes, Priya Kumari, in virtual circuit, a table is maintained which has details of incoming BCI, outgoing, and port number. Yes. So we have a dedicated path. We have a communication between end systems are reserved basically for the I'll say I'll also have the difference here also. Communication between end system are reserved for duration of communication session. Between the systems. And if I talk about packet switching, are these resources reserved in the session, like for the session or not? Used mostly for voice communication. Yes, absolutely. Circuit switching is a method of communication in which a dedicated communication path is circuit. Yes, Shirisha, you're absolutely correct. Yes, in circuit switching, we don't have the resources or basically the reserved resources. I'll give you an example of a daily life. If suppose I have a restaurant example, there is a restaurant. Before going, I called that restaurant and I said, okay, basically this restaurant requires reservation. And I call this restaurant and I say, okay, I want to book my seat there. I book my table there. So please, can you book my table so that we can be seated and order our meal immediately we go to the restaurant. So restaurant owner said, okay, and the table is already booked. Now, when I went to the restaurant, immediately I'll be seated and I'll order my meal. But there is a hassle of calling before I leave the home. Calling the restaurant owner and everything, that hassle is there. Now, the other case, this is circuit switching. I want to establish a connection before. Now, packet switching is like, I don't want to go into that hassle of reserving the table. I don't want to bother. I am saying, okay, I'll go to the restaurant. Okay, it's okay if I have to wait for the table before I'll be seated. It's fine for me. That is basically a packet switching. I hope so. This example is well suited with this circuit switching and packet switching. Now come to one more example, a traditional telephone network. First, a connection is established between sender and receiver. That connection is called a circuit here. That jargon is basically the circuit. And since I'll say like a connection is guaranteed, established, so that is why I say it is more reliable here, because connection is already established. So I can say that circuit switching is more reliable as compared to packet switching. Can I say that circuit switching is more reliable? Now the other differences. One more thing. Okay, that thing I'll. If I talk about one more thing, that what about time? Which will can I say in circuit switching the time is wasted? How it is wasted? Can someone answer me? How the time is wasted in circuit switching? If I'm saying the statement that the time, if no flow of data is there, yes, absolutely correct. What I'm doing is I'm reserving that table, like I'm reserving that connection. Okay, there should be a connection. There is a dedicated circuit, but it is wasteful if the data is not transmitted. If that connection is basically idle. I'm calling someone, I'm saying that I want to connect to that person, but if I'm not speaking anything, the resources are underutilized. This is the time can be a difference, reliability can be a difference, connections, the circuit switching is more reliable, I can say. And basically circuit switching is more complex if I talk about, because first of all connection has to be established there. That is why it is more I'll say more complicated. Which is more suitable for real-time services? Someone has told me earlier also. Again, I'll ask. Which one is more suitable for real-time services? Packet switching, packet switching, packet switching. Everyone is answering. Packet switching, packet switching. Everyone is incorrect here. Circuit switching. How? We were thinking, okay, okay. Now some of the people are answering circuit switching. Okay. Real time means basically if live thing is going on, if a video conference call is going on, a connection is established before only. If a dedicated line, as you're saying, if a connection is established before only, as I have told you, it's more reliable because this connection is dedicated to that. It will not, in packet switching, as we saw that if I'm going to a restaurant, it may happen the table will not be there. So it is not reliable because there was no connection established before. So if it is not reliable for real-time services, it is not suitable. Do you get my point? Are you getting my point? Yes. Yes. So basically it's less reliable, so it is not suitable for real-time services. Packet switching, circuit switching is more suitable, but packet switching has many advantages and packet switching is more efficient. Why packet switching is more efficient? In one side I'm saying it's not suitable for real time, we'll discuss. Obviously it offers better sharing of transmission capacity there. It is more simpler, it is more hassle free. If I talk about restaurant, now let's take an example, a numerical example. Suppose users share 1 Mbps link. and user generates data at constant rate of 100 kbps. And there is a period of inactivity also. Please mute yourself. When no data is generated. 10% of time user is active and 90% of time user is inactive. What about circuit switching? What will happen in circuit switching? $100 kbps will be reserved for each users at all time. I'll say that is what will happen. I'll write here in easy way. Bandwidth per user is 100 kbps. Capacity is 1 Mbps. Can I say 10 users can be active in the circuit switching? Only 10 users, circuit switching will be supporting only 10 users. Even they are active, even they are inactive, but it will support only 10 users. Am I correct by saying that? Yes, I'll give more example, Nivesh. Yes. Is it clear? Now, what about packet switching? When the user is okay, what is the probability? I'll say that 11 users are active at the same time. How can we calculate this? Maybe you know this formula, or I'll please unmute, mute yourself.
अरे 3 seconds वर सेंड करता
इंदर तू भी पढ़ाई कर रहा है? हाँ
There is a lot of disturbance here. I think this example is not cleared. That is why no one is answering. Okay. Lines can be used by multiple packets irrespective of source and destination in packet switching. So more connection can happen. Okay. What I'm asking is, you know about this probability exam, what is this? Binomial, Bernoulli. Okay, I'll not go in then detail with this. Yes, binomial per probability. Yes, this is binomial. Okay, don't go in that depth. If you don't know also, it's fine. So basically what I'm saying, what is the probability that 11 people will are active? So if I say that total of 35 users are n is 35, probability of being active is 0.1, that is 10%. Probability of being active is inactive is, I'm speaking reverse. Inactive is 90%. So basically it's 417225900. Similarly, probability of X is equal to 12. Oh, sorry. So multiplied by 0.1, this is this. Multiplied by 0.1. Okay. I'll come to the 0.0798. This one, wait a second. Now, don't go in that depth, like how calculations and all. The probability of x is equal to 12 is suppose 0.00058 and so on. And the total, basically, it's suppose 0.0004, which means that there are 0.04% chances that the active users are more than 10. And 99.6% chances that the active users are less than 10. So in packet switching also, if more than 10, like obviously it's like we are only allowing in the circuit switching 10 users only. But packet switching, obviously more users are there, and the probability of the collision is very less, or retransmission is very less, as that is 0.004% chances. So that is why I'll prefer packet switching, so that it is more scalable as compared to the circuit switching. Can I say that? Okay, don't go in that depth of example. Just try to understand the intuition behind it, what I'm trying to say. I hope that it's clear that what I'm trying to say is that more users can join in packet switching as compared to circuit switching. Circuit switching, when more of the idle time is there, then the circuit switching is wasting that circuit, that connection there, because it is reserving the resources, whereas packet switching, it is allowing more users there, and the chances of active users at the same time, it's very less in this example, when 90% of the time the users are inactive. Should I proceed further? Yes, more users can join in the packet switching. Yes, I hope so. It's cleared. Now coming to the questions, MCQ questions. Let's come to the first question. What is the primary characteristic of circuit switching? Can someone answer this? B. A, B, A, B. B. Okay, majority of them have answered B. Some have answered C. Okay, what is the primary characteristic of? Wait a second. Let me have water. What is the primary characteristic of circuit switching? Data is divided into packets before transmission. It's absolutely incorrect. Data is not divided into packets. So A is eliminated. A dedicated communication path is established. Yes. The dedicated communication path is established. Resources are shared among multiple users. It's not shared dynamically, so it's also incorrect. It operates primarily at application layer. Incorrect. So answer is B. Should we proceed? It's not dynamically. The people who are answering C. I hope you got the answer. What about the second? Write 2 and answer now. Like 2A, 2B, 2C, 2D, whatever. Which of the following is the example of circuit switching? So everyone is answering correct only. That is traditional public switch telephone network. Third, it's these are basic questions, so that you are, this is just to get that you have got the concept here. In packet switching, how is data transmitted across the network? Now write 3A, 3B. Through a single dedicated channel, in a fixed size cells, in a variable size packets, via analog signals. 3C. Everyone is correct here, 3C. I hope so that everyone is getting the concept clearly. Which switching method is more efficient for bursty data traffic? Before answering 4, tell me what is bursty data traffic in layman words only. In simple words, what is bursty data traffic? And also write the answer. 4B, 4A, 4C, 4D. What is the answer? Bursty data. Okay, I'll tell you first. Bursty data traffic. That's like the example we have done. Like sometimes it's idle, sometimes it's non-idle. It's packet switching basically. We have done now only. in the packet switching, what is there, what is happening there, we are able, the data was bursty 90% of time. It was idle, like the data, they were not sending any data, it was idle only, the circuit was idle only. So packet switching was more suitable, as we saw. Coming to fifth major disadvantage of circuit switching. Yes, you all are correct. Inefficient use of network resources. Which layer of OSI model primarily handles packet switching? Write 6 and then answer. Absolutely correct. Now, what term describes the method in packet switching where each packet is treated independently and may take different paths to the destination? Now write 7 and answer.
त्याचा फोटो काढून ठेव. फोटो काढून ठेव. स्क्रीनशॉट काढ.
Write 7 and answer. Yes, absolutely correct. Datagram switching. In 8th, in circuit switch network, what happens if dedicate path for? I think so. No explanation is required if all are answering correctly only. In a circuit switch network, what happens if dedicate path fails during communication? The system automatically reroutes the packet. The communication is immediately terminated. The system switches to packet switching. Data is stored and forwarded once the path is. Yes, absolutely. Okay, wait a second. Okay, right. 8A, B, B. What is happening when the dedicate path fails? One more thing, if a particular node fails, obviously the whole path is failed and the communication is immediately terminated at that time. That is basically B. Which switching technique is predominantly used in modern data networks like internet? Write 9 and then answer. Okay, I'll zoom in. Is it fine? 9B, absolutely correct. What is the main advantage of packet switching over circuit switching? Absolutely correct. 10th C, better resource utilization. Which of the following best describes virtual circuit in packet switching? We have done that there are two types, datagram as well as virtual circuit in packet switching. Okay. I don't think so anyone has answered correctly. 11th. Everyone is saying a fixed path established before data transmission. 11 C, Aman Kumar, you are correct. Actually, a path is established, or I can say a simulation of circuit. As I told you, yes, the path is established, but that is not a dedicated path. It can change because if a dedicated path is there, a fixed path is there, that is basically circuit switching only. That is not packet switching. Virtual circuit means a simulation of circuit. The path is there, which is not a dedicated path, that is within the a packet switch network. Basically, C. Which protocol is commonly associated with packet switching? Okay, everyone is answering TCP. It's like MPLS also, A and C. Though we haven't, okay, leave that. Though it's multi-protocol label because we are there sequencing also. Yes, it's both because we are there labeling the packet so that we can sequence there at the other hand. Because if we'll not label it, how can we reorder it at the receiver end? So it's both A and C. Okay, in circuit switching, what is the term for the time required to establish a connection before the data is transmitted? What do you think? No, it's not propagation delay. Yes, Jins, Aman Kumar, you are correct. 13th, not 14th. Someone is answering 14th. 13th. It's basically setup time when the connection is basically established. So when we are adding the time, we have to add the time which is for the setup phase also, setup time also. So it's basically, see, I mean to say the setup time is also required, like 0.5 seconds or something. It is required for establishing a connection also. That overhead time is also added in circuit switching. Which switching method inherently supports statistical multiplexing? I'll give you just a hint that statistical multiplexing is like we are dynamically allocating the resources on demand. We are allocating the resources on demand. Now, can you answer? B, yes, absolutely correct. What is head of line blocking issue primarily associated with? Now, before answering 15th question, head of line is like, when I'll say first packet, head of line means I'll write first. Wait a second. When first packet in queue is delayed or blocked, preventing subsequent packets. In same queue from being processed.
What have we written after when? What is it?
Yes. Any doubt?
Yeah. What is it? When I didn't get
When
it.
first packet in queue is delayed or blocked,
Okay.
basically it is preventing the subsequent packet in the same queue from being processed. Okay, I'm sorry, I have the answer here only, the packet switching. So basically it's like when the first packet is blocked because maybe the queue, as we saw that output buffer, there is a concept called output buffer queuing delay. It's because that the packet is dropped because the transmission medium is already busy. So that is why, that is head of line. First packet itself is basically in the queue is delayed. Which switching technique can provide QoS guarantees more easily? Quality of service. Now I want to see whether you'll answer correctly or not. Yes. I think you got the concept. More reliable, more 16, that is circuit switching. In packet switching, what mechanism is used to ensure that all packets are reassembled correctly at the destination? By the name, can you tell me? Sequencing information, absolutely correct. Which of the following is not the characteristic of packet switched network? It's a dedicated channel. We don't have a dedicated channel in packet switching, whereas in circuit switching, we do have. How does packet switching handle data from multiple sources? Nineteenth, how does packet switching handle data from multiple sources? I think no one is answering correctly. I'll give you as a, yes, A, B, D. Okay, think about this. I'll ask in the next lecture. Take a screenshot photo, think about this. I'll not answer now. It's not 3 answers, Aman Kumar. It's only 1 answer. I'll ask in the next lecture the same question. Let's go to the next one. Which of the following scenarios is most suitable for circuit switching? B. Yes, absolutely correct. B. Live voice conversation. As we have already done about that, real time. Should we proceed? These were some of the questions. I hope so. It helped you. I hope so. Should we proceed? Now coming to, I think circuit switching, packet switching is done. Though we have understood about network protocol in much detail, just I'll I'll discuss about the two interfaces which I used. Can't see the chart. Wait a second. So basically, protocols, we have understood that it is allowing to interoperate between devices, heterogeneous devices. These are rules, regulations. So it has two different interfaces. I'll go with that first. Service interface, as well as peer-to-peer interface. If I talk about service interface, okay, can you tell me, I'll ask you guys, can you tell me what is the basic difference between service interface and the peer-to-peer interface? What is the difference? Yes, come on. Service location not fixed, one is remote, other is local. Basically, service is like, it is between adjacent layers within same device. If we are communicating, it's between the adjacent layer, within the same device. Now here it is between same layer. Peer-to-peer means different devices. The peer devices. Or I can say it's like internal communication, because it's the same devices. It's between the same device, and it's the external communication. As discussed in this lecture as well, we have some key elements, that is syntax. I'll just go through it as you have already learned in the lecture. I'll just go it very fast here. Syntax, semantics, and timing. Syntax is like, we are defining here, these are the key elements here. What is the protocol defining? Syntax is like structure, format, I'll say, of data, which can be like header. What is the header? What is the footer? What is the payload? What is the field length, I'll say. These are the formats. The other thing is signal level, which is like, what is the transmission medium? How much should be the voltage? What is the modulation technique? So that other end should know. Semantics, it's like defining the meaning of each section of bits, which have semantics of control information, error handling. If I talk about control information, it's like control flags and all, which we'll discuss, like acknowledgement also is there. Sequence number is there. There should be sequence number, so that order should be maintained. Error handling, which will have either timeouts, retransmission thing. Timing means the speed, synchronization should be there. Sequencing should be there. That is basically the timing there. I hope so these things are cleared. Though I'm going fast, I think so. But Now coming to encapsulation thing. I'll draw something. Let's try to understand. Suppose this is a source. One minute. From next on time, I'll basically draw these things earlier only so that the time shouldn't be wasted. One minute just. Can someone explain me this diagram? What is happening here? So basically, application layer message, I'll say it is passed to the transport layer. Transport layer is taking the message and it is appending in additional information. Application layer message is given to the transport layer. It is appending additional information. And I'll say this transport layer the application layer message as well as transport layer header information, they both are constituting a segment.
Really?
Yes. So basically, they both are constituting a segment here. Now, again, at the other end, and this message is basically acting as a payload for the transport layer. Can I say that? Now, the transport layer is basically encapsulating the application layer message. This is encapsulation. It is encapsulating the application layer message. Now, at the network layer, again, a header information is being added. It is called a datagram here. Now, at the link layer, I'll say it is again adding its header information and it is creating a link layer frame. What is payload? Payload is typically a packet, I'll say right here. From layer above. Basically, from the above layer, whatever the packet is coming, that is a payload. Understood about the encapsulation? Here, then it is going to the switch basically. Then it is going to the router. That is why we have a network layer also. Then to the destination. Each layer encapsulates those information. Yes, you all are correct. Below layers are being accessed. At least, absolutely correct. The payload, the input that is coming to the next layer. I hope so. This encapsulation is also like you have got it. Actually, I have to go somewhere. I'm in the hurry now. We'll discuss about the other things in detail in the next lecture. I think this was the 4th lecture which was discussed in the class. Functionalities and all already we have discussed though. The stack and all those things. Okay, then the application layer and all we'll discuss in the next lecture. And I will upload this lecture, and in the next lecture I'll also give, okay, I'll give you, this is my email ID. This is the name of my YouTube channel. Please take the screenshot of it. I'll upload the video tonight only. You can see the recorded lecture. This is the email ID. Like you can, when will be the next class? Next Tuesday. Same timing, 6 to 8. Yes, Slack link I haven't created right now. I'll create it and I'll share in the next class. YouTube link you can search in my channel only. I'll upload the video today.
Is it, madam, CS21D503
Yes.
at IITTP?
Yes.
Thank you.
Okay. So, any feedback? Quick feedback as I have to go. Should we go to the more questionnaire part, or these, like today the way I have taught it was fine? Yes. Can any one of you unmute and tell me?
The entire thing which
I
we
think
have
it should be
discussed
more
today, that is quite good.
Okay, someone is asking, someone is saying very elaborative, someone is saying too fast. Okay, I'll try to reduce my speed. I'll force mute.
I think it would be better if it is more
More? Yes.
interactive.
Okay, interactive. Yes, actually, I was trying to be more interactive in the starting, but it was like many of you were unmuting and there was a lot of disturbance. So I thought, okay, next time I'll make sure that it will be more interactive. Okay, I'll not be too fast. I'll keep these things in mind. Lot of collision.
Ma'am, you can do one thing, ma'am.
Yes.
Because like everybody is randomly trying to speak, that's why that issue is there. So you should have the control whom to give the assist to mic. So if somebody raises like hand in for one particular question, 2 or 3 people you can allow. That way this this collision will not occur.
Okay.
Yeah.
Okay.
And also another suggestion is that you can mute everybody and then whenever needed only unmute. You can take the control of muting also completely everybody.
Okay. Okay, I'll try to be more slow next time. I'll try to I'll mute everyone, and I'll try to be more interactive, and hope so this lecture was fine.
Ma'am, one more suggestion. If you could include more MCQs, then it will be more beneficial for us.
Okay. The way
Because-
I have shared today, the circuit switching and packet switching, I'll have problem based.
That is good. That is good practice, ma'am. For all other topics, at least have few questions, if not more. Because it will force us to challenge ourselves and think in different way. So it is good to practice, ma'am. So accommodate this kind of thing for all topics which you are going to cover in future.
Okay.
This was nice for you, ma'am.
I'll come with more questionnaires. Okay. Thank you, class.
ma'am.
Thank you. Yes, I'll include more MCQs.